Sir, unmute.
Yes.
Sir, screen sharing you are. होगा sir.
The real and apparent friendship. So, yes, what's the doubt? Okay, everybody silent. There is a third doubt. Doubt is what is the relation between wavelength and refractive index, right? So we already know mu21 is v1 upon v2. But what is speed expressed as frequency into wavelength index of medium? Frequency does not change.
Yes.
Okay. So what is therefore mu21 is equal to lambda1 upon lambda. So this is the wavelength in the medium, refracting medium, right?
Yes.
What is the refracting medium? The second medium. So this means if one is air. So what is mu2? Okay, this is the relation. There is an inverse relation. So this is air. Lambda तो air में lambda अगर है, तो medium में क्या relation है? Refractive index of the medium and wavelength in the medium. This is how it is. ठीक है? So bigger wavelength will deviate less, bend less. Bigger wavelength bends less. So red will bend less because its wavelength is maximum. Violet will maximum because its wavelength is least. Understood? So just write this expression. Okay, so I think there is one topic left in unit C. So what is that? So this is unit C topic. Bending of stick. Is it stick?
Yes.
When immersed in
Sulfuric acid.
water. Or you can say liquid. Liquid है ना क्या है? Liquid.
Water.
Is it water?
Yes.
ठीक. तो देखो क्या होता है? Now, this I had already explained actually. ठीक है? Some of you did not pay attention. देखो. Let us say this is the original stick.
Sulfide.
This is the original stick, right? You have an observer here. An observer is watching from here. So this point to this observer, he will feel. So if one ray goes straight, it will go like this. You will have to take another ray, let's say in this direction. So if this is the normal, what will you feel? It will bend away.
Then two rays.
Okay, na? So this is water, second medium is water, first medium is air. So, and this is your stick actually, stick. It is not ray of light. So let's mark this position as A and B. So where does this position appear to him? It will appear to him as here. This is B dash. So this stick will appear to him like this. Right. So likewise for all the point, right? They will go up. So stick will appear bent like this. I had asked you, I had given this task to you. Take a bowl of water, put your pencil in it. It should look bent to you. How many of you tried? Did it appear bent? Very good. And if you put a coin, you put a coin in the ball, right? You are able to see the coin, right? Everybody, you have a coin in the bowl, okay? You are able to see. Now raise the height, raise it till you stop seeing the coin. Hold it there. Now start pouring water. You will see you are able to see the coin. Do this experiment if you have not done it. Huh? Let's take a cup. उसमें तुमने coin डाल दिया. अभी तो देख रहा है तुमने coin डाला. Try to raise it side. When the edge blocks the coin view, you will not be able to see the coin there. Now in that situation, start pouring water in it. You will see the coin is visible again. Because now the light is bending when it is coming out. When the light is bending, then the coin apparent position will be raised up. Right? So you should then be able to see the coin. This is very practical. You can do it at home. So this was the only topic left, I think, which I had already at the beginning explained. When I discussed the application of, and I've also explained how a swimmer or a fish will see the tree. So it is that diagram. You want me to discuss this again? An object in the rarer medium viewed from a denser medium. There you go. The second one is मैंने कर तो दिया था, but you want me to do that again? That example was ठीक है बता देता हूँ फिर भी देखो. Suppose an object in rarer medium viewed by observer in denser medium. ठीक है? ऑब्जेक्ट कहाँ पे है? रेयर मीडियम में. अब देखो उल्टा सीन हो गया. This is air, this is water. Where is the observer now? Inside the water. Okay. Now you have any object here, let us say. Again, what will you do? You will take one ray as normal, along the normal. Let us say the object was here. So one ray along the normal, it goes inside. Other ray, Now, what will happen? It will bend towards the normal, right? Because it is denser. ठीक है, ये ऑब्जर्वर का प्लेसमेंट थोड़ा ठीक कर लो, यहाँ पे कर लो. Let us say he was observing from here. So what will you feel? You will feel this object was not here, but
It will
up.
appear like this.
So the apparent position of the object will shift upwards. So if it was any tree, let us say any diver was looking at the tree, those trees will appear taller. So this is the ray diagram. This is some hypothetical object.
Yes, sir.
It will appear, say, lamp post. Now there was lamp post. Clear?
Yes.
So these are some effects of refraction of light. So in this chapter, do we have any numericals?
Yes.
In unit C? There are some consequences. You just read through it. Take time to go through the consequences. See if you need any help in understanding. ये करा दिए थे? ये भी करा दिए थे. I think we have discussed all this. So there are 3 numericals. My book. How many numericals are there? We have done the numericals. So I'll give you the clue. Silence, everyone. We will now do numericals. Okay? So let's do the numericals. Unit C. So we have water. Water bond appears to be. This is numerical 1, right? Yes. Read the data. Is it different than in my book? So your apparent depth is 2.7 meters.
Yes.
If the refractive index of water is, in your book it is 3. Apparent depth, right? Appears to be is apparent depth.
Yes. 3 meters.
And what is the refractive index of water? 4 by 3. So what is the actual depth? Right? So what is the actual depth? So apparent depth is equal to actual depth divided by refractive index. So therefore, D is equal to D into, what is it? This is 3 into 4 by 3. This is 4 meters. Okay? So the real depth is 4 meters. Second numerical. What's the data in your book?
Refractive index 4 by 3. And real depth.
So we have coin placed at the bottom of the beaker containing water. So this is actual depth.
Yes.
12 centimeter.
16.
By what height the coin appears to be raised? So this is shift.
Yes.
So what is the shift? Let's call shift as X. What is the formula for shift? One minus 1 by mu W. Okay, this is what it is. So shift is 16 into 1 minus 1 by 4 by 3. This is 16 into 1 minus 3 by 2, which is 16 into 1 by 3. This 4. Okay, shift is 4 centimeters. So you have to be careful. Sometimes shift is asked, sometimes apparent depth is asked. Okay, so the answer will be different. Also, then kept below rectangular glass tab of refracted index 1.5. So mu g is 1.5. When viewed from vertical, it appears to be raised by. So shift is given. Raised by 7 millimeter. Calculate the thickness of the glass slab. So thickness will be actual depth. Okay, the thickness is the full depth of the glass. So this is what to find out what will be T. So since x is equal to T minus d by glass this time. So what it is? You have to find T, right? अरे ये क्या हो गया? So x is equal to d 1 minus 1 by mu. So d is equal to x divided by 1 minus 1 by. This is what it is. It is 7 millimeter, right?
Yes, sir.
Is this the data same as per my book?
Yes, sir.
7 divided by 1 minus 1 upon 1.5. 10 minus 1 is 9 by 15. This is 7 into 15 divided by 90. How much is it? 3 is 9. 8.7. So this is 7 by 2.35. 3 1 3. 2.1 35.3 ये क्या हो गया? 15 minus 1 is 14, right? 14 by 59. 10 by 15 was
15 minus 10 5 by
4 by 15.
5 by 15.
5.
1 by 1 by
1 by 3. This is 7.
21 here. So it's
Yes. ठीक है, you're getting 21. Okay. So you have to get the logic right. Only mistake can happen in calculation. Chalo, shall we begin now with unit T?
Yes, sir.
Give me some space. This chapter has been taught in any of your schools? Not yet.
Solving machine speed multiplier पढ़ा है मैंने सुना
So first concept is concept of critical angle. देखो so far अभी तक हमने कौन सा वाला केस स्टडी किया है? लाइट ट्रेवलिंग फ्रॉम rarer to density. For this unit, light is traveling from denser to rarer. Okay, so unit D, light traveling denser to rarer. All these concepts are applicable only when light is traveling from denser to rarer. तो इस केस में क्या होता है देखो, let us say you have a denser medium. Pay attention everyone. Roy, pay attention. ठीक है? Second medium is denser medium. First medium is rarer as always. Now light is traveling from denser to rarer. तो क्या होगा देखो? Which angle we call as critical angle?
Critical angle.
It is a particular critical angle. Particular angle of incidence, we represent it as IC, for which the angle of refraction is 90 degrees. Yes. You understand? So what happens is, whenever, let us say you have different angle of incidences. Let us say there is one angle of incidence like this, right? So it will go away. So if you go on increasing the angle of incidence, there will be a situation when this outcoming light will start grazing the surface. That specific angle of incidence for which you get angle of refraction in the rarer medium as 90 degree, that angle of incidence is called critical angle. Okay?
Yes, sir.
So, how do you write? When light in the denser medium is incident, is refracted, in rarer medium. Right, incident. Now the incident medium is denser medium, is refracted in rarer medium, such that the angle of refraction in rarer medium is 90 degrees. Then the angle of incidence in the denser medium is called critical angles. Is it clear?
Yes, sir.
So let's find the relation between critical angle and refractive index of the medium. Is it only draw the black color? Huh? Where is the reflected ray? Refracted ray? Here. Towards the surface. It grazes the surface. Okay. That time this angle of incidence is called critical angle IC. Bilal, you understood what is critical angle? Explain. Yes. Okay. So having understood what is critical angle, its symbol is IC. So relation between IC and mu. Next.
So when an incident play,
Diagram देखो.
when an incident ray refracted an denser medium,
Rarer medium. Refract कहाँ पे होता है? हमेशा denser to rarer में हो रहा है. हाँ. ठीक है, चलो समझ में आ गया ना? तो क्रिटिकल एंगल नहीं हुआ ना. क्रिटिकल एंगल एक स्पेशल एंगल है जब वो 90 हो रहा है. इट्स नॉट जस्ट एनी, उससे कम या उससे ज्यादा वो एंगल ऑफ इंसिडेंट. एंगल क्रिटिकल एंगल भी एंगल ऑफ इंसिडेंट है. कहाँ पे? टेंसर में. हाँ, कोई भी नहीं हो सकता. जब वो एंगल जब रिफ्रैक्टेड 90 मिलेगा तो वो एंगल ही क्रिटिकल है. ठीक है, समझ आए? Let's find the relation. So by Snell's law, consider this diagram. By Snell's law, what is mu21? Is it mu21 or mu12? What is the refracting medium? mu12. ठीक है, लेकिन हमको रिलेशन किसमें निकालना है? इस मीडियम के रिफ्रैक्टिव इंडेक्स में. दिस इज व्हाट? mu2. हमको mu2 और IC में रिलेशन निकालना. mu2 और IC में निकालना. ठीक है, सो mu12 क्या देगा हमको? साइन ऑफ IC अपॉन साइन ऑफ 90. ठीक. सो अब what is mu21? 1 upon mu21. ठीक है ना? और mu21 को हम क्या लिख सकते हैं? जस्ट mu2. ठीक है, so therefore 1 upon mu2, because ये क्या हो गया? अगर ये एयर है और ये ग्लास है तो क्या मिल गया हमको? Sin I. This means mu2 is equal to 1 upon sin I. ठीक है, पहले स्नेल्स लॉ अप्लाई किया, फिर बाय डेफिनेशन ऑफ एब्सोल्यूट रिफ्रैक्टिव इंडेक्स mu21 is mu2. ठीक है, वो सारा रिलेशन हमने यूज किया है पहले का. ठीक है, so this is the relation between the refractive index of the denser medium and the critical angle in it. Both, where are they? These are both the property of denser medium. Where is IC and where is mu2? Denser medium. Clear? नहीं समझा? नहीं समझा? क्या नहीं समझा? मैंने क्या बताया? स्नेल्स लॉ कैसे अप्लाई हो रहा है? अभी ऐसे अप्लाई हो रहा है ना, मतलब मीडियम 2 से मीडियम 1 में जा रहा है. तो रिफ्रैक्टिंग मीडियम कौन सा है? मीडियम 1. इसलिए हम पहले रिफ्रैक्टिंग मीडियम लिखते हैं 1 2, और 1 2 में एंगल ऑफ इंसिडेंस IC है, एंगल ऑफ रिफ्रैक्शन 90 है. साइन 90 इज 1. साइन 90 क्या होता है? 1. इसलिए ये बच गया. अब मैंने क्या बोला था? हमको किसके बीच में रिलेशन निकालना है? बिटवीन IC एंड mu2. बोथ आर प्रॉपर्टी ऑफ द डेंसर मीडियम, उनके बीच में निकालना. तो अगर डेंसर मीडियम का रिफ्रैक्टिव इंडेक्स ज्यादा है तो उसका क्रिटिकल एंगल कम होना है. तो लीस्ट क्रिटिकल एंगल किसमें होगा? डायमंड. ठीक है, डायमंड का क्रिटिकल एंगल होता है 24. टेबल दिया तुम्हारे बुक में, देखो. IC फॉर डायमंड सबसे कम क्या होता है? नहीं 24 डिग्रीज है 25 ना 24 25 के आसपास। अब देखो क्रिटिकल एंगल से होता क्या है, आप सुनो पहले, ठीक है। क्रिटिकल एंगल से होता क्या है देखो, हमने क्या देखा है, देखो अभी समझो लाइट ऐसे आ रही थी यहाँ पे, लिसन, लेट्स से पहले हमने नॉर्मल की तरफ डाला, इंसिडेंट एंगल 0, नाउ वी आर, इज एवरीबॉडी लिसनिंग टू मी, पे अटेंशन हियर एवरीवन, angle of incidence is 0, angle of incidence is 0, it will go straight, slightly increase, now it will be in the rarer medium, it will have some angle of refraction greater than angle I,
Yes, sir.
है ना, R is always greater than I, now you reach IC, now IC is the limit, when the angle of refraction is 90, what if now you increase it further? It goes inside.
Reflection.
So what you get is total internal reflection. There is no refraction. That's the beauty of critical angle. So this will act like a mirror then, this boundary. Once in the denser medium, angle of incidence increases the critical angle, then the light is totally internally reflected. It's called TIR. Understood? So you will get, if so many examples, it's now so that's why diamond glitters. अब diamond का critical angle है 25 degrees. So if light enters in diamond, एक बार light enter हुआ, वो अंदर ही अंदर reflect होते रहता है, TIR. So that's why diamond glitters. So it's an art to cut a diamond such that you make so many surfaces within the diamond that once the light enters, it cannot escape out of it. Always the angle of incidence is around 25. Got it? Or more than 25. It is cut in such a way, so that is the skill. So diamond cutting polishing is done in such a way that once light enters it, it remains internally reflected, and that's why it glitters. Okay, so that's what is.
That is also how they determine which is a fake diamond and real diamond. Means
That is a different thing. I mean, I'm not expert on that because that's a different area. What is critical angle and why diamond glitters? You understood? Okay. So anything, any medium, if its critical angle is known to you, how can you find out critical angle of any medium by this activity? If you know the refractive index of any medium, how will you find the critical angle? So sine of IC is equal to 1 by mu2, and therefore IC is equal to sine inverse of this. Okay, from the sine table you can find out. IC is equal to sine inverse 1 by mu2. So if you have a sine table, you can find whatever value you get here, for which angle, sine of IC is this value. You can figure out the angles. Okay, sine table is there in the book, right? Maths book, yeah. You can take a long table and. So what you need to know to find the critical angle for any medium is, to find the critical angle of any medium is, you just need to know its refractive index. ठीक है? पेपर में मिल जाएगा. All right. Let's understand what is CIR.
Sir, physics में logbook देते हैं?
Yes. देंगे ना? क्यों नहीं देंगे? एग्जाम में देते हैं ना? अब टोटल इंटरनल रिफ्लेक्शन के लिए shall I send the last 2 benches out? The last 3 benches. देखो हर बार बोल के वो सुधरते नहीं हो. Pay attention. जिस डायरेक्शन से मुझे आवाज आएगी वो सारे पूरी रो बाहर जाएगी, ठीक है। So TIR, what is total internal reflection? If this question is asked, you will need this diagram. Let us say there is this object, right? Now what is happening is you are slowly increasing the angle of incidence at this surface. Let us say this is one normal. When the angle of incidence is, say, I1, this is I1, then it will be slightly refracted. You increase the angle of incidence slowly. I have already demonstrated. Now you have a greater angle of incidence, I2. So it will bend further. Right? Out here, now you have, let us say, critical angle. Now this is further increase, it is critical angle. So this is 90. So this is R1, R2. Everywhere R1 is greater than R2. Whenever it is denser to air. Okay. But here R is 90 degrees. Okay. Again, it is greater than IC. Right? Now here what happens? When the angle of incidence is greater than critical angle. Total internal reflection. Okay, what you will get is total internal reflection. So is it better reflection than in case of mirror? This is I is equal to R in this. Is this better reflection than mirror?
No, sir.
Yes, it is 100% reflected. In mirror also some light is absorbed. Okay, or if the silver coating is dull, you don't get full reflection, right? This is 100% reflection. So that is why there are certain special prisms which employ total internal reflection to reflect light. Got it? We don't use mirror over there, like in cameras, binoculars. Prism is used for reflection, not mirrors. Okay? So in total internal reflection. So what is this I? This I is greater than critical angle. So what is happening at this place is called as total internal reflection. Is it understood? Right? So what are the two conditions for total internal reflection?
When I1 is greater than I2.
So first conditions for TIR. First, you have to know what is TIR and conditions. First condition is light must be traveling denser to air. Light ray must travel from denser to air. This is the first condition. Two, angle of incidence should be greater than critical angle in the denser way. It's not required because when you say critical angle, it means it is in the denser way. You can't have a critical angle in here. Okay. That's about total internal reflection. Now let us learn about some applications. So factors affecting critical angle. Critical angle depends on refractive index. So anything which affects refractive index will affect critical angle. So one is wavelength or the color of light. Or color of light. So how will critical angle be affected by that? So it is directly proportional to wavelength of light. Why? Because IC is inversely proportional to mu as well as wavelength. So therefore this will be directly proportional. So when wavelength increases, critical angle also increases. Okay. Second, temperature. So temperature of the medium. Which medium? Denser medium. So again, the temperature is, IC is directly proportional to temperature. Yes. So if the temperature rises, critical angle also rises. Because with rising temperature, what happens to refractive index? Decreases. Okay. And if refractive index decreases, so you should know this relation to basically ऐसा है ये रिलेशन है साइन ऑफ IC मतलब उल्टा रिलेशन ठीक है तो इसके लिए यहाँ पे डायरेक्ट रिलेशन क्लियर नाउ एप्लीकेशंस ऑफ TIR So you find applications of TIR in reflecting prisms. Reflecting prisms. There are various types of prisms that we'll study. So what are the types of prisms we have? Right angled prism. तो राइट एंगल प्रिज्म्स में क्या हो जाएगा 45 डिग्री 45 डिग्री 90 डिग्री 45 ठीक है these are called reflecting prisms shall I erase this side
Yes, sir.
So basically you will use it. The first application is deviation by 90 degrees. Suppose I use the prism like this. This is 45. This is 45. Now this is a glass prism. For glass, critical angle is 42 degree. Right? So you have to remember this. 42 degree. Critical angle for glass is 40 degree. IC for glass. तो एक ग्लास और डायमंड ये दो याद रख लेना न्यूमेरिकल में खाली ये दो याद तो अब देखो क्या होगा Now look here. How many faces you see? The hypotenuse, the perpendicular, and base of the prism, right? So if the light ray enters from perpendicular like this, what is the critical angle? What is the angle of incidence? Angle of incidence will be 90. This is 45, 45, 45. Whole thing is 90. This is 45. So if the critical angle is it greater than 42? So what should happen? Will it be refracted or will it suffer TIR? TIR. So again it will suffer TIR, right? Because angle 45 is greater than 40. So it will not be refracted. It will suffer total internal reflection. And this is along the normal. So it will come out. So this is incident ray. This is emergent ray. What is the deviation? What is the angle of deviation?
90.
Original direction or इसमें कितना हुआ 90 degree. Okay. So this is deviation. This is the first application. To achieve deviation by 90 degree. So you can show two rays this ray will also suffer the same thing. So first application is deviation by 90 degrees. Everybody understood?
Yes,
sir.
Okay. Next is deviation by 180 degrees. Deviation by. Where will we use it? So you have to know the deviation and application. It is used in periscopes. Periscopes, right? Use another prism. Okay. So use another prism and then you will go like this. Yeah. How it should, so how's it in a pipe, right? So the captain inside the ship, and this could be, you can increase this distance. So if it is a mirror, the image obtained will be lighter. But with prism, you'll get a bright image because there is no loss of optical information. Is that clear? So this is application in periscopes. No loss of light during reflection. Right? Second is deviation by 180 degrees. So if let us say you have placed the prism like this. Now the 90 degree is up. And this is 45 degree. Now the incident ray is in this direction. Again, what is the angle of incidence? 45? Yes. This is the incident ray. So now it will be totally internally reflected. What will be this then? This is 90. You're saying this is 45. This is 45.
Yes.
So this is also 45. Right?
Yes.
Isn't it? Is it parallel to this? So this will again be angle of incidence and emergent ray. What is the deviation? What is the original direction of the incident ray? 180. Got it?
Yes.
How do you calculate deviation with respect to the original incident ray? So it is 180 degree. So what do you achieve? If you take one more ray, this also will suffer same thing. So if you had any object like in this position, say AB. So A वाला कहाँ पे आ रहा है? इधर आ रहा है. So it will be inverted, right? A dash.
B dash.
So it is used in camera, binocular to invert the image. Okay, application कहाँ पे होता है इसका?
So camera.
You don't need to go for the ray diagram of it. Just understand application in binoculars, cameras.
So J diagram looks like this.
Just this. Yes, this ray diagram will be needed. Okay, so everywhere the angle of incidence is greater than 45. Okay, critical angle कितना है? 42. That's why your here is TIR. TIR.
मैं वो भी mention करना पड़ेगा.
मतलब कर दो, better है. ठीक है, application in wire to invert. So this is deviation by 180 degrees. Then in a slide projector, one more application of right angled prism. Okay, so inversion of image. without deviation. So there is no deviation in this case, but you still get inversion of image. So in this case, the input, again the prism is kept on its hypotenuse. Prism is kept on its hypotenuse. Okay, 45. This case में क्या होता है? Now tell me what will happen now? It will refract now. Okay, it will refract in this fashion. Now this is greater than IC, so TIR here. Again, it will refract like this. Okay, understood?
Yes.
TIR happening at the base.
Yes.
Every other phase, the angle of incidence is less than critical angle, so it will refract. Right? Let us say another way. Again, it supports the same fate. It comes out like this. So TIR only happens here. Refraction at the other phases. So if you had an object like this, let us say AB was like this, how do you get the image? A comes down, A dash. Okay, so there is no deviation because input ray, output ray in the same direction. Okay, but now you have a, so where is the application? Slide projector. Okay, in slide projectors it is used. You feed the object inverted so that you obtain spread image. 85 तक है ना? Sorry, 835. I said 85. 835. So we have one more case, one more name. कितने case हैं? बहुत सारे हैं. Equilateral prisms. So that is deviation by 60 degree. How many deviations we saw? 90. Now